Now what I'd like to do is take a look at working through some examples of balancing equations. So instead of just showing things on a PowerPoint or the ideas, actually work it out on pen and paper to give you kind of an idea of how you can approach these ideas or how you can approach these problems and kind of point out some issues. First, balance the following equation. CaOH2 plus HCl becomes CaCl2 plus H2O.
So we want to balance this equation. And we know for balancing, what that means is we want to work one atom type at a time. And we want to figure out which ones would be the best place to start, and where would be the worst place to start. So the atom types that we're looking at, we have Ca, we have O, H, here we can see H again, and then Cl. So calcium, oxygen, hydrogen, and chlorine. And what we want to do is work through those one at a time. So we need to balance all four of those types of atoms. You want to think about what order we want to do it in. And what we really want to key in on is not so much where we do start, but where we don't start. And so what we can look at is we can see that if we look at hydrogen is in this reactant and hydrogen is in this reactant. So if we were going and trying to balance it, hydrogen would be really a problem because we balance by adding coefficients. Where do we add our coefficient? In front of this compound or in front of this compound? It's not really clear what we should do, so we're going to save hydrogen for the end. If we look at calcium, one reactant, not that one product, not this one, oxygen, only right here, oxygen, chlorine, only right here, and chlorine is only right here. So any of those three would work. Usually I just work from left to right, but any order that there is no wrong answer there, any of them will do the trick. So we're going to do calcium first. So let's take a look. So what I'm going to do is I'm going to say I'm going to do calcium. And so what I'm going to do for calcium then is I'm going to figure out, I'm going to draw a little squiggle to denote my difference between reactants and products. And what I can do is I can say, well, there's a 1 functionally in front of that. So 1 is the coefficient. The subscript on calcium is 1. So that would mean I have 1 calcium atom. I have no calciums in HCl. Okay, so that's still fine. For this, if we look on the product side, calcium is right here. Again, it's going to be 1 times 1. That's equal to 1, where this 1 comes from the coefficient, which there's nothing written there. That implies 1, and there's a 1 right there, and then there's nothing right there. So calcium, we can see as the equation is written, I have 1 calcium atom on the reactants, 1 calcium atom on the products. That is balanced. So I have the same number of calcium atoms on each side. No work is needed for that. That's great. We'll go next. We will step into oxygen. So I'll go ahead and do O. Okay. If I look at the O now, I'm going to start here again, and there's still a 1 out front of this. So the coefficient is 1. So now the question is, how many oxygen atoms are in each formula? And so we can see there's this 2 in the parentheses. And if we remember that 2 means that it applies to the H and to the O, because really there's 2 hydroxides. Okay? So that means each one of these, there's 1 O per ion, and I have 2 of the ions. So that means this is going to be, whoopsies, a 2, okay? Which means that I have 2 O atoms. There are no O atoms here. So I have 2 oxygens and 2 hydrogens. 0 oxygens in calcium chloride. And now I have water. And if I look and see at water, the coefficient out front is a 1. Right here, my coefficient, my subscript, sorry, the number low, so 1. So as it's written, I only have 1 oxygen atom on my product side. This 2 only applies to the H. So this is unbalanced. I don't have the same number of oxygens on each side as it's written, so I need to do something about that. And what I want to do is add a coefficient. Adding a coefficient increases the number of that type of molecule, thereby increasing the number of that type of atom. So we're always going to add the coefficient to the compound where I have fewer atoms. So you can see this is 1, this is 2, 1 is lower, so I'm going to increase this value. And the question then is, what number do I use? In order to figure it out, I take 2 and I divide by 1. 2 divided by 1 is going to be 2. So what I want to do is I want to put a 2 in front of that. So then that means I get rid of that. That becomes a 2 because I have 2 of these molecules, meaning 2 times 1 is now 2. So because I put the 2 in front of the hydrogen, in front of the water, this is now a balanced for oxygen, right? Instead of the 1 water, I need 2 water molecules. And that will lead to a balanced equation for oxygen. So calcium is good and oxygen is good. We also want to check when we add that, do we affect the calcium? We can see that there's no calcium in the water molecule, so we did not unbalance the calcium by, like, say, adding more to one side. Okay. So calcium's good, oxygen is now good. We wanted to save hydrogen, so I'm not going to do that. I'm going to do chlorine. So the Cl, chlorine. Calcium hydroxide has no chlorines in it. Hydrogen chloride, there's a 1 out front still, and a 1 in there, meaning I have 1. Calcium chloride, you can see there's a 1 out front, and then 2 in there, meaning I have 2. Right, that 2 applies to the calcium. Sorry, to the chlorine, not to the calcium. And there's no chlorines in there, which is good. So once again, we find unbalanced. We are unbalanced. I'll switch to green for this one. So this is an unbalanced equation because my chlorines, I have different numbers of chlorines. And again, I want to ask, where am I going to put that coefficient? Right? Where am I going to put the coefficient? It's always going to go on the side with fewer total atoms. This is a 1, right? And this is a 2. 1 is lower than 2. Okay, so we need to deal with that, and the number that we need to put is 2 divided by the 1 that I have. So I need to put a 2 in front of the HCl. Instead of 1, that becomes 2. Instead of 1, that becomes 2. So one of the things you'll note is that that 2 goes out front. I can't put the 2 in the middle or to only touch the chlorine because the molecule is HCl. And I need to have 2 of those molecules. Okay, because each molecule contains one chlorine atom, and I need 2 total chlorine atoms. So I need to multiply the entire molecule by 2. By putting that 2 there, that does affect the hydrogens equally, just like the chlorine, and that's okay. That's how this is meant to work. And so we could see that that's our case. We're now balanced. So we have 2 of those molecules. We got 2 of these molecules floating around. Calcium is balanced, oxygen's balanced, chlorine is balanced. My final one is 8. I wanted to leave it till the end. So it would be, I wouldn't have to be, it would be the most difficult to deal with. Let's see what it looks like. Okay, so hydrogen. This calcium hydroxide still has a 1 in front of it. Just like the 2 went to the oxygen, the 2 also goes to the hydrogen. So there's 2 there. So I have 2 hydrogen. This 2 that we put in front of the HCl also affects the H just like it did the Cl. So there's a 2 out there. The coefficient or the subscript on the H is still a 1, meaning I have 2 right there. Calcium chloride does not contain hydrogen. Now water, there's a 2 out front, and there's a 2 in the subscript. There are 2 water molecules, each containing 2 hydrogen atoms. Bringing me to 4. When I look at balancing this, these 2 need to be added together. Both of those are involved. I have 2 hydrogens in this compound, 2 hydrogens in this compound. Together, I have 4 hydrogens across my entire reactants. And then on the products, there's no hydrogen in calcium chloride, but there's 4 across my 2 water molecules, because each contains 2 hydrogen atoms. If we had started with hydrogen, we probably never would have guessed that we needed to put coefficients in front of 2 of these compounds. And that's why we didn't start with hydrogen. It had the most complicated solution because it's in the most places. And it is unlikely that we could have just figured that out without doing it. But we'll notice that by balancing the calcium, the oxygen, and the chlorine first, all of which were more straightforward to do, it was clear. We always go to the lower one, we can multiply it out. Hydrogen just becomes balanced, and we avoid having to do a complicated step that if we had started with hydrogen, we probably wouldn't have balanced it in a way that would have lasted through balancing all the other atom types. So deal with the least complicated ones first, save that complicated one for the end, and chances are it's just going to be dealt with. And so if we want to put this all together in a clean depiction, we would want calcium hydroxide solid plus 2 HCl aqueous becomes calcium chloride aqueous plus 2 water. And so we can see, importantly, none of my formulas change. None of my phases change. The only thing that changes are 1, 2 coefficients. We change those coefficients to balance everything out. Calcium chloride and calcium hydroxide don't have coefficients. That's fine. They don't need them. They don't need coefficients. Everything that does need a coefficient has gotten it. And so that is a balanced equation.
Balance the following equation. FeCl3 plus Ba3N2 becomes BaCl2 plus FeN.
So we want to balance this equation. FeCl3 plus Ba3N2 becomes BaCl2 and FeN. Again, we're going to work one atom type at a time. If we look, Fe in one reactant, Fe in one product, chlorine, one reactant, chlorine, one product, barium, one reactant, barium, one product, nitrogen, one reactant, nitrogen, one product. So there's nothing that's a bad choice. We're just going to work our way left to right. So I'm going to start with Fe, which is iron. Fe, draw my little squiggle down the middle. 1 in the front times the 1 that's down there means that that is 1. Okay. Barium nitride has no ions in it. Barium chloride has no ions in it. There's a 1 out front, a 1 at the bottom. Give me 1. This is the 1 out front. No number down there. 1 out front, no number down there. As written, iron is balanced. Okay, so keep working our way along. Let's do chlorine. In this case, I have a 1 out front of here times the 3, that's the subscript. Nothing in the barium nitride. Barium chloride now, 1 times 2 is equal to 2, right? That 2 subscript, and nothing in the iron nitride. All right, so chlorine is not balanced. Normally when we go to balance it, we would ask which side has fewer chlorines, and it would be the 2, right? And so then we'd say 3 is greater than 2, so 2 times what equals 3? And that is, or 3 divided by 2 is 1.5 or 1.5, 3 halves. Ideally, we want whole numbers when we're balancing, so we can't do that. What we can do when we have this sort of situation where these numbers are not divisible by each other is what we can do is we can take this 2, put that right here in front of the chlorine, in front of where this chlorine is. We take the 2 over here, put it in front of that. We take this 3 and put it in front of that. Okay, so we basically take the coefficients, take the total, and make that the coefficient of the other side. Okay? And so then what we can see from that is that goes away, that becomes a 2. 2 times 3 is 6. That becomes a 3. 3 times 2 is, once again, 6. So now my chlorines are balanced at 6. Basically what you're doing is you're just multiplying each number by the other, which is guaranteed to give you the same constant, right? You had a 2 and you had a 3. If you just multiply by each other, they're both 3 times 2, which is equal to 2 times 3, right? It doesn't matter the order that you do that in. Multiplication is commutative. And so you get a nice 6 total chlorines. The thing we want to be careful of is now that we've balanced chlorine, we put a coefficient in front of FeCl3. So the process of balancing chlorine affects what we already did for the iron, right? If we take a look, this isn't a 1 anymore, it's a 2, meaning that this is now a 2. Okay, which now means iron is unbalanced. My Fe atoms, I have 2 on the reactant side, which I need to have in order for chlorine to be balanced, right? This 2 wasn't random. You need it for chlorine to be balanced. So basically, making the chlorine balanced affects the iron, and then I need to affect the iron to balance it, right? This was a 2 times 1. This also needs to be 2 times 1. We can't change that coefficient, right? Or we can't change the formula. We can't put a 2 like in the middle of this to only affect the chlorine. It has to affect the entire compound, so all of FeCl3 gets doubled. And it's okay, we can just deal with it. That's one of the reasons why showing your work in these problems is going to be really beneficial, because it allows you to really cleanly see, like, ooh, these coefficients need to be the same all the way down. If I change it to be a 2 for chlorine, that also affects how many ions are present in the reaction, right? Now that needs to be balanced. So chlorine's balanced, iron is balanced. We've done all this work, we're only 2 in. We can go ahead and take a look at barium. Barium has a 1 times 3 is 3, right? The 1 out front, the 3 down there. Barium here, there's a 3 in the front times 1 down there, 3. So on things it's now, oh, this one, sorry, there's nothing in there. So we can see that by balancing the chlorines, we also have balanced the bariums, right? We got that for free by doing the chlorines first. Finally, let's take care of the nitrogens. Nothing right here. 1 times 2 right there. Nothing right there. And again, 2 times 1 is 2. So those are balanced as well. So by taking care of iron, chlorine, we broke iron, fixed it. Barium and nitrogen are just also balanced as is. So if we want to write out our total overall reaction, we have 2 FeCl3 plus Ba3N2 becomes 3 BaCl2 plus 2 FeN. No coefficient on the barium nitride, totally okay. You got coefficients on everything else. All 3 atom types are balanced. I do want to make a quick note. There's no phases on this. That's because I was just lazy when I wrote this, if I'm being honest. And that's okay. You don't need, if there weren't any phases given, don't worry about adding phases. Sometimes people don't use them. But balancing can never be skipped. You always need to balance any equation that you're ever given. It is not correct if it is not balanced.